All right, so for this video, we talked about object classes last time. We did our silly little dog thing, and we instantiated a dog. We made him bark, set his name, things like that. This time we're going to talk a little bit about inheritance, go through a simple inheritance example with just nothing, just to show that it works. Public fields, show how they work and how they can be accessed from child class objects. You remember we had public fields in our dog, and we were able to directly access them from client code. Well, in inheritance, you're looking at the superclass and being able to access them directly from the direct, class that your object was instantiated from is one thing, but they have to be public for that. Public methods, we can call them from client code, and then we can call the one from the superclass as well if we need to. Objects from the or methods from the superclass can be called from the class from which your object is derived. And then constructors, there's some tricky bits to constructors with inheritance because the superclass needs to be constructed as well. If you're not using the default constructor, you need to call its, well, either way, you need to call its constructor or, it's just not going to work. So let's do that, and then we'll dig into this other stuff later. So for inheritance, let's create ourselves a new project. Inheritance. And that all looks fine. There it is. Now let's create a new class. This will be our client code. And we do want a public static void main. All right, so that's it. Program entry point. This is where it's actually going to start running. It's not going to do anything just yet. I don't like that to do there. So I'm thinking for an example, let's use a teacher. Let's say we're going to instantiate a teacher object. Teacher object is a. That's an important little phrase they use when you're talking about inheritance. You might be talking about inheritance if you say a dog is an animal. A teacher is a, human. Let's say a teacher is a human. So let's make a couple more classes. Let's make our teacher class and our human class. So the teacher class will inherit the human class. So let's do a new class called human. And then a new class called teacher. All right. Oh, I didn't use that little creator thing to do some magic that it offered to do for me. We'll just type it. And it's called, this little bit here, it says it extends human. That's all we need. We just created a object class called teacher that inherits from the empty human class. There it is. So let's create a human. Let's create a teacher rather. So data type is a new teacher with empty parameter list. Will this work? Yes. Just won't do anything. It's useless, but it works perfectly. Okay? So we just instantiated a teacher called Mr. Harding from the teacher class, which inherits the human class, which does nothing. Okay, so let's talk about fields that a human might have. These are attributes of a human. Humans might have a, an age. They might be handsome, charming. They might have hair color. Things like that. Okay. So again, these are going to default to an empty string. What does a Boolean default to? I don't know, probably null. I don't care. And age defaults to 0. So if we run this code, we just created a guy who has named Mr. Harding, who is a teacher, which inherits the human stuff and has the default values. So that's not super useful just yet. Those are public, so we could access them same way we did with the dog. We can call system out bloody hell, print line. Yeah, we can do that, I'm pretty sure. Ta-da, 0 years old. Because we made it public. And again, we talked about that's probably a bad idea, but that's just the way it is. And that's all the way up in the human class, okay? We didn't have to do anything special to say that we want it from the human, not from the teacher, because the teacher doesn't have any attributes of its own. It inherited them all from human. It got a copy of all these. So if there's methods up here too, say hey, and it does system out print line. Hey. Now, it's not going to happen because we didn't call it from our client code. Our client code is going to go Mr. Harding say hey. And it helps you, puts it right there for you. You just double click on it and bang, there it is. Mr. Harding says hey. All right, and that works because these are public and they are in the class from which teacher inherits its stuff. All right. You can also have private methods up here as well. They will not be visible by an object instantiated from the child class. They wouldn't even be visible from an object instantiated from the human class because they're private. But that's enough about that for now. Let's see, what else did I want to go over? Where the heck? There we go. Public fields, we can access them. Oh, and even now here, again, I talked about what's bad about these public fields. I'm going to say Mr. Harding dot is, or I'm sorry, charming equals true. Was that one of our fields? Ooh, can we get to that actually? I don't know. Let's find out. Yeah, so now I'm charming. And you probably don't want that. You probably don't want people to be able to reach up into these fields and set them from client code without being able to constrain what they're doing and make it make sense. Maybe you won't want them to set that. Maybe you want that to be set on based on some other things. Okay, public methods called from client code. I did that. So in the teacher class, if we wanted to, well, let's do the constructor. Let's talk about a constructor. A constructor is nothing more than a method with the same name as the class. So is that all we have to do? Oh, I'm saying words. And it has a parameter list. So you can put it with, you can create it with none. Probably more useful to create it with something else. But anyway, if we try this from here, will this work? Let's give the teacher a couple of fields. Let's say a teacher is, let's say, good at Java. And the teacher could also be good at teaching. Okay, so when this gets instantiated, what's going to happen now? Will this work if we just run this? Yeah, it's not barking. But these are all instantiated to default values, which are, I think, null for Booleans. But we want to, let's say we want to actually set these when the object is instantiated. So let's use Boolean Java and Boolean teaching. For the Boolean, are they good at Java, are they good at teaching? And then we'll just do this thing where we just set them. Okay, so what we've done is we've broken our client code because it calls me with an empty parameter list. That'll blow up. They'll say there's no such thing as teacher with an empty parameter list. So we need to give it the I was hoping it was going to populate that. Oh, there it is. Boolean, Boolean. Yeah, it just says Boolean, Boolean. Doesn't say what their names are. And I'm having trouble remembering already. They are Java and teaching. So, Mr. Harding, is he good at Java? No. Is he good at teaching? No. So we're going to send false and false when we instantiate Mr. Harding. That works. I'm still 0 years old because the superclass didn't get its constructor called, so everything just defaulted because it doesn't have a constructor. So if it does have one, let's give it one. Doesn't matter, we'll give it an empty list and we'll just say, yeah, let's go ahead. We know where we're heading with this. Let's give it a parameter list. We'll give it a Boolean is handsome, Boolean is charming, and string hair. And we're just not going to make them the same to make life easy. So handsome equals is handsome, charming equals is charming, and hair color equals hair. All right, so that's fine. That should work, right? Now when we try to run this, it'll explode because the constructor with no arguments doesn't exist anymore. Our client code tried to construct the teacher, which does have arguments in its constructor, but because it doesn't call the human constructor, it just punted and used the default. There is no default because we overrode it with this one. If you create an explicit, not technically an override, but if you create an explicit constructor, the default constructor doesn't work anymore. The constructor with no parameters that Java creates by default and you can't see doesn't work anymore. We broke it. And in this case, that's fine, okay, because that lets us get to something that I wanted to talk about in my list over here, which is super. All right, so the constructor for teacher, this is the constructor. Implicit superconstructor human is undefined. So we're going to need to construct the human explicitly by calling the super. That's it. The word super says do something up at the super level. And if we don't specify a method, it's going to say you must mean the constructor. All right, so let's call it. And what were the parameter lists? My handsome, charming, and my hair. So we're going to say, well, yes, he's handsome, and of course he's charming, and his hair is gray and thinning. So what this does, let's type it. And again, we didn't have to do this before because the default superclass constructor got called and that worked, okay? But once we started trying to do things in the superclass constructor with a parameter list, the default constructor doesn't work anymore. We have to explicitly call super with our parameter list. Okay, let's see if this works. Seems to work. Now, what we've done here is instantiated a teacher in client code and said that he's not good at Java and he's not good at teaching. It's not real obvious from looking at this. It's just false, false. Let's make that's dumb. Let's see. Let's see. String. No, they're Boolean. My bad. And then we can make this look a little better. This is just making it look better. So these expressions, which are just variables, get evaluated and they get replaced in the actual parameters. These are the formal parameters, good at Java. The actual parameter is going to be false. This should still work. It does. We never set age, did we? Why am I still 0 years old? Oh, we didn't set it. LOL. Okay. Doesn't matter. Not important. So say we want to have, let's see, let's look at my list of things I wanted to go over. That's why constructors. Okay, so that's inheritance. We talked a little bit about accessing the superclass constructor, accessing the superclass public methods and private superclass methods. All right, let's stop here because this is pretty long. What we've done is gone over the basics of inheritance, okay? Simple inheritance, public fields, public methods, constructors. We're going to make a lot of these things private and use some accessors and some mutators and talk about encapsulation and why private superclass methods might be something that's actually useful.